In this video, we are going to continue where we left off from the part 1 video. Now, in the last video, we talked about negative exponents and dividing monomials. Today, we are going to first focus on properties of exponents. Sometimes on algebra tests or exams, you will see those problems where you have an exponent raised to another exponent. Let's say we have x to the 5th to the 7th power. In a situation like this, what do you think we need to do? Whenever you raise an exponent to another exponent, you multiply the two exponents. So you have x 5 times 7, which gives you x to the 35. One way to think about it is, you have x to the 5th, x to the 5th, x to the 5th. X to the 5th, x to the 5th, 1, 2, 3, 4, 5, 6, and then one more x to the 5th. Alright, so we have x to the 5th 7 times. So that's like saying you have 5 x's here, 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 7 times. So that's why you get x to the 35th power. Notice if you count all these x's, you will have 35 x's. This is why the answer is x to the 35th. Here are some other examples that we could try. Now take some time and try these problems on your own. Alright, let's try these problems. X to the 2nd to the 4th power and x to the 3rd to the 7th power. So x to the 2 times 4, and this one's going to be x to the 3 times 7, well, 2 times 4 is 8, so we have x to the 8th. 7 times 3 is 21, so we have x to the 21st power. That's all you have to do for those examples. Now sometimes you might see a number in addition to a variable inside the parentheses. So in this case, what do you do in a situation like this? You have 2 x to the 5th to the 5th power, as well as 5y to the 4th to the 6th power. Well, you still need to multiply the exponents on the inside of the parentheses with the one on the outside. Now, the 2 may appear as if it doesn't have an exponent, but in fact it does. It's an invisible 1. So what you need to do is multiply the 1 times the 5 which gives you 2 to the 5th. Then you have x to the 5th times 5, which gives you x to the 25. So on this one you have 2 5th x to the 25th, which gives you, so the 2 to the 5th exponent equals 32, and then you have x to the 25th power. And this is your answer for this one. Okay, so now we have 5y to the 4th power all raised to the 6th power. So you have 5, 1 times 6, y to the 4 times 6, which is 5 to the 6th, y to the 24th. Therefore, you get 15,625 y to the 24th. That's your answer. Okay, now let's try this one. Let's say if we have 4 to the 3rd, x to the 6th, y to the 3rd, all raised to the 2nd power. So the first thing we need to do in this problem is to multiply all exponents with the 2 on the outside. So we got to multiply this one, we got to multiply these 2, and we got to multiply these 2. Okay, so we have 4 to the 3rd, 3 times 2, y, or x, to the 6 times 2, y, to the 3 times 2. So what does that equal? Well, 4 to the 3 times 2, we have 4 as the base, and then 6, 4 to the 6th power. Then you have x to the 12th power, y to the 6th power. And that's your answer. Okay, this, I forgot to, this should not be a coefficient raised to the power. It should be an actual number. So let's go and simplify this further. So 4 to the 6th power would be 4,096 x to the 12th power, y to the 6th power. And this should be our answer. Okay. Let's do another problem. Let's say we have 4 to the 1th power, x to the 2nd, x squared, all raised to the 4th, times 2 to the 1st power, x to the 4th power, all raised to the 3rd power. Okay, first thing we need to do is the distribution process. So over here we have 4 to the 1 times 4 x to the 2 times 4, and then 2 to the 1 times 3 x to the 4th times 3. Okay, so right here it would be 4 raised to the 4th power, x raised to the 8th power, 2 raised to the 3rd power, and x raised to the 12th power. Okay, now we need to simplify these two expressions. So 4 to the 4th power is 256. X to the 8th. And we have 8 to the x, 12. Okay, now we need to multiply the coefficients. 256 times 8, 256 times 8, which is going to be 248. Then we add the exponents attached to the variables, which is 8 plus 12, which gives us 20. So we have 2048 x raised to the 20th power, and that's going to be your final answer. Now let's try another problem. Let's say we have 3 to the 1st power, x to the 2nd power, y to the 6th power, times 2 to the 1 power, x to the 3rd power, y to the 6th power, all raised to the 3rd power. So let's start with the distribution of the exponents. Alright, we have 3. Oh, this should be the second. 3 to the 1 times 2, x to the 2 times 2, y to the 6th power times 2nd power, all in parentheses, then 2, 1 times 3, x 3 times 3, y 6 times 3. That gives you 3 to the 2nd power, x to the 4th power, y to the 12th power. Then you have 2 to the 3rd power, x to the 9th power, y to the 18th power, 3 to the 2nd power, x to the 4th, y to the 12th. Then we have times 2 to the 3rd power, x to the 9th power, y to the 18th power. From here, we figure out what the coefficients are. So we have 9, x to the 4th, y to the 12th. And then we have 2 to the 3rd is 8, x to the 9th power, y to the 18th power. Now we have 9 times 8, which gives us 72. x to the 4th plus 9th y to the 12th plus 18th, which gives us 72x to the 13th power, y to the 30th power. And this is your final answer. Now, what if you have a problem like this? You have negative 5x to the 4th, y to the 3rd, all raised to the 0 power. Well, anything raised to the 0 power is 1. So, negative 5 to the 0 is 1. Negative 3 to the 0 power is 1. Negative 15 to the 0 power. So keep that in mind. This includes all problems where something is raised to the 0 power. So what's the difference between these problems? So go ahead and calculate these problems on your own. We have negative 3 squared. We have negative 3 in parentheses squared. Then we have negative 3 in parentheses squared. So how do we go about these problems? Well, negative 3 is negative 3 times 3, which is a negative 9. Negative times positive is negative. Okay? The next problem, well, we have this negative 3 in parentheses. So since we have that, whenever you have an even number of negative signs to multiply, the answer will be positive every time. Being inside the parentheses, this means the negative is affected by the exponent. So we have negative 3 times negative 3. Well, negative times a negative is a positive. So we have positive 9. We have a negative, and then we have negative 3 times negative 3. Well, negative times negative is positive. Positive times negative is negative. So we have negative 9. These will be your answers. Now let's look at this problem. Let's multiply a monomial by a binomial. 2x to the 1 power times 7x to the 1 power plus 10. Okay, sometimes you will see this type of problem in algebra courses and tests, so it's helpful to understand how to do these problems. First, we need to multiply the 2x times the 7x. Well, that's 14x squared. Then we multiply the 2x. We did that one. Then we multiply the 2x times 10, which gives us positive 20x. So 14x squared plus 20x is going to be your answer. Now let's go ahead and do another problem. Let's multiply a monomial by a trinomial. What's the first thing you do in this problem? So we have 6x to the first x squared minus 4x to the 1 power plus 5. Okay, well, we multiply the 2x to the first power times x squared. So we get 6x to the third power. Now let's multiply 6x to the first power times negative 4x. So we have negative 24x squared. So now we do 6x to the first power times 5, which gives us a positive 30x. So then our answer will be 6x cubed minus 24x squared plus 30x as our final answer. Now let's do one more problem like this. Say we have 8x to the first power times x to the third power plus 2x minus 8. What do we have to do here? Please pause the video and try it on your own first. Alright, now we multiply 8x times x to the third gives us 8x to the fourth. Then we multiply 8x times 2x, giving us 16x squared. Now we multiply 8x times negative 8, which gives us negative 64x. So our final answer is going to be 8x to the fourth plus 16x squared minus 64x. Well, that's it for this video. I hope you got a lot of value out of this video. If you have any questions, please put them in the comments down below. If you like this video, hit the like button and don't forget to subscribe to my channel for more math-related content. Until next time, see ya!